Now let's talk about general module concepts. If you double click on a module, it'll open up what's called its inspector. This is the way that you can make changes to the module. Inspectors are available in both design mode and in tuning mode. I can also right click on a module and say view properties. This pulls up the module panel, and you'll see that there's several different tabs. First one is variables. So you can see, for example, this module has a gain variable. That's the one that was on the slider. It also has other variables, smoothing time and isDB, that are only available on the property sheet itself. What I can do here is I can type in exactly what I want the gain to be, or I can also change the min and max. So suppose I want the min to be 12, minus 12, and the max to be 0. Then when I open up the inspector, the range of the slider is only going to be from 0 to minus 12. I can also set a step. Okay, if it's empty, that means I can type in any value. If there's a step, then it's going to quantize to the specified step size. So here I'm quantizing to half a dB values. Another tab that's available is the Arguments tab. And the Arguments tab changes things which affect memory allocation. So we saw this before on the delay module, where with the delay module, I can specify what's the maximum delay in milliseconds. And in this case, I can also specify which memory heap is used to store the delay buffer. The Argument tab is only available in design type because it affects memory allocation and wiring. Other things you'll see, for example, on the deinterleaver, you could specify how many output pins it has. So if you want to deinterleave 3 channels, we're going back to 2 channels. And so that's available again on the Arguments tab. Often, if you don't see a variable you're looking for, it might be specified as an argument. Other things that generally use arguments would be the length of an FIR filter or the number of stages in a biquad filter. Another thing you'll see on the module properties is there's a Properties tab. Here I can change the name of the module. For example, I could call this left delay. And the module name has to be a C-compliant variable name. That means no spaces, can't start with a number, and so forth. You can also change other things like the size and the color and so forth. We won't do that now, but those things are available. And finally, the Build tab is for advanced things which control memory allocation, when the system's built, and so forth. We're going to talk about this in a later section. Another feature that's fundamental to modules in AudioWeaver is the module status. This is a property of every module. And a module can be in one of 4 different modes. First, it can be active. That means it's processing the audio. If it's muted, the processing function is not called, but instead we write zeros into the output wire. If the module is bypassed, we copy the input to the output. In the 4th state, inactive, we do nothing. We talk about that more later, but this is used for debugging and profiling. To change the module status, you right-click on it, and then you select the desired status. This works both in design and tuning modes. You can select multiple modules, change the module status all at once, and it can even be applied to subsystems. Let me show you what this looks like in practice. Let me go ahead and build and run our AudioWeaver system. We're going to hear the piano music play. And I'm going to lower the gain of the scaler here. So it's at minus 8 dB. And I'm going to right click on the scaler and I'm going to change it to bypass. And you'll hear it got louder. In fact, it got 8 dB louder because now we're copying the input to the output. So the scaler is essentially not being used anymore. You can go back to active, it attenuates it again. And then I'll go to muted. In that case, zeros are being written into the output wire and we don't hear anything. Let's look at general module guidelines. So for modules, if there's a time, like a delay time or smoothing time, specified in milliseconds. Gains are in linear units, except when explicitly labeled with dB. When you drag out a module, a default name is provided. You can always change that. You can right-click on a module to get help. And we saw how modules can be configured via inspectors, module status, and the property sheet. A lot of modules have built-in smoothing. For example, the scalars have that. And the smoothing eliminates discontinuities in the audio when you make changes. So when you move a slider, there's no pops or clicks. The smoothing in the scalars is performed on a sample-by-sample basis. Okay, it's part of the processing thread, not the control thread. And we use a first-order IIR smoother. That is, we use a first-order low-pass filter as shown below. So here it shows an instantaneous gain change. So I changed the gain from 1 to 2. And after the smoothing, we get a slowly ramping kind of first-order exponential ramp until the desired target gain. Since we're using first-order smoothing, after one smoothing time has elapsed, we get 63% of the gain change. And after 3 smoothing times, we have 95% of the gain change. Let's go ahead and listen what the smoothing sounds like in practice. Here I have a basic AudioWeaver system that contains a sine wave going through a scalar, and then we turn it into stereo to go out. So I'm running this in native mode, and you can hear when I change the gain, it's nice and smooth without any discontinuities. Now let's look at the property sheet here, and we're going to change the smoothing time to 0. So that means no smoothing happens. And now when I move the slider, you're going to hear the pops and clicks from the instantaneous gain changes. Again, if I add the smoothing now, see I go to 100 milliseconds, then it'll all be smoothly varying. No risk of pops or clicks. Another concept in AudioWeaver is that most modules support multi-channel operation. That is, they can work on mono, stereo, or any number of channels in a wire. And for most modules, the same gain or filter coefficients and so forth is applied to all the channels. There's also a set of N-channel modules that allow you to specify a different tuning parameter per channel. For example, there's a general purpose scalar, same gain to all the channels. There's a vector scalar, different gain per channel. And then we also have mute, mute N, invert or invert N, where the N-channel modules are the multi-channel ones. Let me go ahead and show you what the vector scalar looks like. Here's the standard system from before. I'm going to make a little more room, and I'm going to go ahead and add that vector scalar. And then I'm going to build and run. What happens is the vector scalar now has 3 sliders. There is a master gain that's applied to all the channels, and then a trim gain per channel. Just a little louder. And then I'll open up the output meter, and now I can turn this down, and you can see now only the right channel goes down, left channel goes down, and similarly both channels are affected when I adjust the master gain. So on the left we have the general purpose scalar, same gain to all the channels. On the right is the vector scalar, where we have a different gain, trim gain per channel.